All right, in this little mini lesson, we are going to explore the angle properties of angles that are in between and so interior to and exterior to parallel lines. So I have two lines here that are parallel to each other. They're horizontal, and there is a transversal going through. I've not labeled the lines nor the transversal. I've only labeled the angles. So yesterday we looked at how angles can be labeled using the endpoints and the vertex if they're labeled. So for example, if this was point A and that was B and that was point C, this would be angle A, B, C. Another way that we can label angles is just simply by putting letters where the angle would be, or numbers. It makes it quite a lot easier to label them and much faster. So you can see here I've made a list of the angles that we are going to measure. So one of the things that we need to be able to do is to be able to explore the properties of angles in parallel lines is we have to gather some evidence. So we are going to do some deductive thinking, and we're going to gather some data. So we're actually going to measure the angles. So we'll need a protractor to do this. Now, you should all have protractors for this course. To measure an angle, the protractor has the crosshairs. You place the crosshairs at the vertex of the angle. So if we're going to measure angle A and C and B and D, the crosshairs will have to be right at that intersection point of the two lines. So we carefully place the protractor there and we line it up. And so we want to measure this angle. So we start from 0 and we look back, and it appears that the angle is 10, 20, 30, 40, 90, 100, 110, 120 degrees. So angle A is equal to 120 degrees. I don't have the degree symbol on here, I think. Oh, maybe there is. Oh, maybe. That's hopefully. Nope. There is no degree symbol. All right. So I'll just do it like that. Maybe I'll do it as an O. There we go, 120 degrees. All righty. We'll next measure angle B. So now angle B, we have to take our protractor and we're gonna have to move it. We want to measure the angle here. So there's two ways we can do it. We can line up the protractor along the transversal, or we can flip the protractor over and line it up along this line here. So I'll do that instead. So I'm going to flip the protractor, making sure that it's parallel. And I'm going to line it up here. There we go, crosshairs, and we'll measure. So we measure 10, 20, 30, 40, 50, and we get 60 degrees. So the angle B is equal to 60 degrees. Okay, we'll carry on. Measure angle C. So flip the protractor again. It's a bit easier for you because you can actually use your hands. I have to use this, okay? And we'll line it up at the crosshairs. It's not exactly lined up. There it is. So we measure 10, 20, 30, 40, 50, 60 degrees. So angle C is 60 degrees. You'll notice that angle B and angle C have the same measure because we actually gathered data. So we did some deductive thinking and we gather data, and we know they're equal because we measured them. Lastly, we'll measure angle D. So we'll flip the protractor over. And we measure 10, 20, 30, 40, 50, all the way around. We measure 120 degrees. So angle D is equal to 120 degrees, which is equal to angle A. And notice that angle A and B add up to 180, and angle A and C add up to 180. Angle B and D add up to 180, and angle B and A add up to 180. When two angles add up to 180 degrees, we call them supplementary angles. So I'm going to jot that down here. That's actually an important property. So angles that add to 180 degrees are called supplementary angles. Notice that supplementary angles are on a line, and they are on either side of a transversal. So A and C are supplementary, B and D are supplementary, A and B are supplementary, and C and D are supplementary. That can be quite useful because if angle C, let's say, is 10 degrees, then we know that angle A would have to be 170 degrees because they have to add up to 180. Okay, so we've got these four angles, A, B, C, and D measured, and we'll continue on and we'll measure angles E, F, G, and H. So we'll flip the protractor over and we will measure angle E. So angle E, as we measure, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, it's 120 degrees. So angle E is 120 degrees. Angle E is equal to angle D. Angle E is equal to angle A, again, using deductive reasoning here because we've gathered data. Now, because we know about supplementary angles, we would anticipate that angle F, which should be equal to 60 degrees, and we've got the protractor in place so we can measure it. Angle F is 10, 20, 30, 40, 50, 60 degrees. So angle F is 60 degrees, it's equal to angle C, and it's equal to angle B. Okay, angle G. We have to flip the protractor over. So I'm just gonna rotate it in this case. Make it easier because it's keeping it on the vertex. There we go. So angle G, as we count 10, there's 90, there's 110, 120 degrees. So angle G is equal to 120 degrees. And we would expect angle H to be equal to 60 degrees, but we'll confirm with measuring 10, 20, 30, 40, 50, 60. It is equal to 60 degrees, and angle G and H as well are supplementary. Okay, so we've gathered data. There we go. Okay, so we've gathered data, some angle measures, and we can explore the properties. We can clearly see that there's some angles that are equal to each other here, and there's angles that are supplementary. So the first thing we note is that angles A and D are equal to each other. We'll look in this section here. So angle A and D are equal to each other. So angle A and angle D are congruent, so we put a little tick mark there. As well, as we can see, angle B and C are equal to each other. So angle B and angle C two tick marks to differentiate. They're equal to each other. So why are they equal to each other? All right, we notice that they are vertically opposite. And we learned yesterday that vertically opposite angles are equal. So this is confirming through measuring that angles A and D, B and C, they're vertically opposite angles. Vertically opposite angles are congruent. Okay. We would expect then that angle E and G would equal each other. Let's confirm. E is 120, G is 120. Correct. And F and H should be equal to each other, and they are both equal to 60 degrees. So that is important that we just confirmed. Okay, what's going on here? It's weird. Okay, we've just confirmed that vertically opposite angles are congruent to each other. Okay, so I'll erase this. Okay, so we know that vertically opposite angles are congruent. So I think I'm gonna type this over here. Different color. And to make it go quicker, I'm going to abbreviate it VOA for vertically opposite angles. So number one, vertically opposite angles are congruent, which means equal. It's faster to write it. Okay. Alrighty. The next set of angle properties we're going to look at are the corresponding angles. Remember, a corresponding angle is an angle, they have to be on the same side of the transversal, and one has to be exterior and one has to be interior, and they cannot be adjacent. So C and D, they're adjacent, they can't be. So C is the exterior, and so then the interior that's not adjacent would be F. So we're going to see what those measures are, angle C and angle F. So angle C is 60 degrees, angle F is 60 degrees. So through measuring, through inductive reasoning, we've learned that the corresponding angles are equal to each other. So let's check angle D and angle G. Again, these are corresponding angles because they're on the same side of the transversal. One is exterior and one is interior, and they're non-adjacent. Again, they're not beside each other. So angle D and G, let's take a look at what their measures are. Angle D is 120, angle G is 120. They are congruent. So again, we've learned that and confirmed through data that corresponding angles are equal to each other. So then let's look on the left side of the transversal, and the corresponding angles would be A and E, and then B and H. So A and E, A is 120, E is 120, they're equal. And B and H, B is 60, H is 60, they're equal. So we've learned then that corresponding angles are equal, are congruent. Number two, corresponding angles are congruent, which means that if we knew the measure of angle A, 120, we would not have to measure angle E. We would know that it's 120 because it's corresponding to angle A. Alrighty, let's explore then the alternate interior angles. Okay, so the alternate interior angles, remember they have to be in between the parallel lines, and they're on opposite sides of the transversal. So we have D is on the right, so then D is alternate interior to E, and B is alternate interior to F. So let's take a look at angles D and E. D and E are both 120, they're the same. And B and F, B is 60 and F is 60. They're also equal to each other. So alternate interior angles are equal to each other, and therefore congruent. It's also interesting to note that the two interior angles on the same side of the transversal, so D and F and B and E. D and F, D is 120, F is 60, they add up to 180. And B and E, 60 and 120. So interior angles on the same side of the transversal are supplementary. So that's a little side note there. Okay, so what we can conclude then is number 3. Alternate interior angles are congruent. Let's expand that a bit. Okay, look at the 4th one after. So let's take a look now at the last, and those are the alternate exterior. So again, alternate exterior, first of all, have to be exterior angles. So A and C, H and G, they're exterior, and they have to be on either side of the transversal. So C is an alternate exterior angle to H, and A is an alternate exterior angle to G. So let's take a look at A and G and C and H. A is 120, G is 120. So A and G are congruent. And C and H, C is 60, H is 60. They are congruent. So what we have just confirmed through measuring is that alternate interior angles, A and G, C and H, are congruent. I should have said alternate exterior angles are congruent. Okay. So alternate exterior angles are congruent. So those are the angle properties between parallel lines. They're important properties. They will allow us to determine unknown angles without actually measuring. Okay, we don't always want to have to measure angles because that can be a bit tedious. So again, as a little side note, supplementary angles are important. They add up to 180. Okay, so they are supplementary angles would be adjacent angles. Okay, on opposite sides of the transversal. So A and C, B and D, E and F, H and G, A and B, E and H, F and G, and C and D. Those would all be pairs of supplementary angles. So what we've just done today is learned how to measure the angles, reviewing measuring angles. The 8 angles when 2 parallel lines are intersected by a transversal. And we explored the properties of these angle pairs. Again, the angle pairs are the supplementary angles, vertically opposite angles, corresponding angles, alternate interior angles, and alternate exterior angles. So that concludes the basic overview of angles and parallel lines, and good luck with the rest of your learning.